Arithmetic sequences. A sequence is a list of numbers that follow a pattern. If the sequence is arithmetic, the pattern is that the same number is continually added to get from one term to the next. For example, the sequence 3, 8, 13, 18, and so on is arithmetic, as 5 is added each time. The number that's added each time is called the common difference. And in formulas, we'll use the letter D to stand for the common difference. And so in this sequence, our first term, which would be a sub 1, is 3, and our common difference is 5. So this example wants us to write the first 6 terms of the arithmetic sequence, given the first term is 7 and that the common difference is -2. So -2 will be continually added to get from one term to the next. The first term is 7. The second term would be 7 plus -2, which is 5. And then we add -2 to the 5 to get the third term. Add -2 to the 3, which is 1, and the fourth term. Add -2 to the 1 to get the fifth term, -1. And the sixth term, we're adding -2 to the -1, and it's -3. So there are the first 6 terms. Then we're asked to find the indicated term of the arithmetic sequence if given the first term and the common difference. Now we're asked to find the 30th term if the first term is -6 and the difference is 7. Continually adding 7 until we get to the 30th term would be time-consuming, but there's a formula to do this. To find the nth term, whether it's the 30th, the 100th, the millionth, whatever, of an arithmetic sequence, the formula is a sub n equals a sub 1, which is the first term, plus n minus 1, where n is the number of terms, times d, the common difference. So if I fill in from this example, I want to find the 30th term, and that equals the first term, which is -6, plus, parentheses, the number of terms would be 30, minus 1, times the common difference of 7. And so when you work all that out, it comes out to be 197. And so we know what the 30th term is going to be without having to add 7 30 times. This example asks, write a formula for the general term, in other words, the nth term, of the arithmetic sequence. Do not use a recursion formula, and then use the formula to find a sub 20. There's a little d missing there. And so we can see that 5 is being added each time in this sequence. So that means d is 5, and we can see that the first term is 2. So what they're wanting us to do is fill in the general formula, not knowing what n is. So there's the formula for the nth term. So we don't know n this time, but we know the first term is 2. We don't know how many terms. We know the common difference is 5. And then we simplify that, distribute the 5. A sub n equals 2 plus 5n minus 5. So the general term is 5n minus 3. That's the general. And that will work for any n value. And then they want us to use that to find A20. So A20 would be 5 times 20 minus 3, which is 97. Sometimes we're asked to add up the numbers in an arithmetic sequence. In this case, it says find 2 plus 4 plus 6 plus 8 plus so on all the way to 200, which would be the sum of the first 100 positive even integers. The formula for that is that the sum equals n over 2, n being the number of terms, and then in the parentheses it's the first term plus the nth term, or the last term. So to solve this example, I'm trying to find the sum of the first 100 terms. N is 100 over 2, parentheses, my first term is 2, plus my last term, or my 100th term, is 200. So it's actually kind of a simple little formula, and the result is 10,100. This is also summing up an arithmetic sequence, but now we have summation notation, or sigma notation. And so the sigma, the E, Greek letter sigma, means to add. It means sum. I equals 1. 1 tells us what I will be at the beginning in the first term. And then 20 tells us what I will be in the last term. And you continually add, replacing the I with 1, then 2, then 3, then 4, and so on all the way to 20. So we're asked to write out the first 3 terms. The first term, I would be 1. So that would be 6 times 1 minus 4, which is 2. The second term, I would be 2. 6 times 2 minus 4, which is 8. Third term, I would be 3. 6 times 3 minus 4, which is 14. And then it also said the last term. So 20 is as high as we go with this summation. So a sub 20, the 20th term would be 6 times 20 minus 4, or 116. So that's the last term. Then they want the sum. So we'll use the formula that we just talked about. S of n equals n over 2 times a1 plus an. And so the last term is the 20th. So we're finding the sum of the 20 terms. 20 over 2 times first term is 2 plus 20th term is 116, and that all comes out to be 1,180.